Hello, good morning. I hope you can see my screen. I'm Dennis Diefenbach, the CEO of the QA company, and I'm going to present this talk, QAnswer Question Answering over knowledge graphs and text. So the outline of the talk is the following. First, I want to show you how we can query a knowledge graph with natural language. Then I would like to show you how to query documents with natural language. I'm going to show how we can combine querying both knowledge graphs and documents at the same time. I'm going to show you a couple of use cases, and at the very end, I'm going to show you a ChatGPT clone that is running on our infrastructure. So in general, QAnswer is the main product that we offer. It's a question answering platform. So it's a platform that allows to construct question answering systems on top of proprietary data, and it's available under app.qanswer.ai. So let's start with the first part, which is querying knowledge graphs. Before I show you how to do that, let me give you a quick understanding about what is the relation between a knowledge graph and the natural language questions that we can ask on it. This is my most technical slide, so stay with me. So we have this URI, which is of type cocktail. We say it's a margarita, there is some description, and then we have tree property consists of three things, and these three things are listed here: Cointreau, tequila, lime juice. And basically this piece of information models a margarita cocktail with some ingredients. And based on this snippet, we expect to be able to answer questions like, what are the ingredients of a margarita? What is a margarita made of? Give me cocktails containing tequila or cocktails containing tequila and Cointreau. So now I'm going to log in to QAnswer, and I'm going to create a question answering system over a knowledge graph. So we need an RDF file as the one that we saying before, and this one is I will call cocktails KG, cocktails KG. And I'm going to upload this RDF file, which contains a knowledge graph about cocktails. It contains a list of cocktails, how to prepare them, and some metadata information. So the knowledge graph was relatively small, and it's now uploaded and indexed, and we can query it. So the first thing that we can do is that we basically search for our margarita instance, and we would get a facet search about this entity. So we have alternative labels like Bob and Rita, consist of Cointreau, lime juice, and tequila. This was the information we were seeing before, and some other metadata. So we can ask things like, what are the ingredients of margarita? And we would get exactly these ingredients, which is the one that we expected. What are cocktails with tequila? And we would get a list of cocktails that contain tequila, including our margarita that we were seeing before. So when you upload an RDF dataset, you get this question answering capability, you get some UI. This UI we can customize a bit. For example, we can say, oh, in this graph, there is this specific property that is used to express images. And then we can express it here. And this would basically trigger the fact that in the auto-completion, also this image is proposed so that we have a better idea about what the instance is. And also in the list, in this list view, this image would appear. Furthermore, generally in knowledge graphs, there are something like definitions that we want to specify. So also here we can go to the UI mapping and basically add this as a definition. And now if we ask for Vampiro in this, no, the Vampiro has no description. If we ask again for Margarita, sorry, and we go to this list view, we would get the description of it together with the image. There is some further customization that we can make. So we want not this facet view as a first UI element, but rather first the images, then the list view. And now if we ask a list of cocktails, we would get this image view with all the list of cocktails that we have in the graph. And last, we could ask something like how to prepare a margarita. And we would get also this information from the knowledge graph. Pour all ingredients into a shaker of ice, shake well, and strain into the cocktail glass rimmed with salt. Some other things that I wanted to show. So together with uploading an RDF dataset, you get also a Sparkle endpoint over this dataset. You can execute normal Sparkle. And we can ask here also to generate some Sparkle, like give me the cocktail with the most ingredients. And basically, we have a language model that would generate for you this query, which is relatively complicated. We can also execute it. And basically what it does, it takes all the things of type cocktails, the ingredients, and then we count the ingredients. We order by the ingredients in descending order, limit 1. So it would have taken some time to generate this query. And maybe we can try also, give me the cocktail, give me the ingredients of the cocktail with the most ingredients. Let's see if this comes out. Oh, this is not give me the ingredients of the cocktails. Sometimes it's just, sometimes one can try twice. Okay, this one looks better. So basically, there is the sub-select query where we find the cocktail with most of the ingredients, and then basically we are retrieving the ingredients of the cocktails. Okay, this was for querying knowledge graphs. Now we go to the second step, which is querying documents. So generally in an organization, you have a lot of structured information, and knowledge graphs are perfect to basically encode structured information, but there is also a lot of unstructured data which is contained into documents. And generally when we want to answer questions, we want to answer questions which answer might also be contained in documents. So what is the relation between documents and questions? In this case, we take an article of Wikipedia, the article of Wikipedia about cocktails, and this article contains something about the history, about the etymology of the word cocktail, how it developed over the year. And basically, given this content, we would like to be able to answer the corresponding questions on top of it. So what we are going to do, we add now a document-based question answering system, which I call cocktail cock. It's also not very important how it's called, cocktail text. And what I'm going to do is that I'm going to upload this printed PDF from the Wikipedia page. Now the data set is indexing, it's indexed, and we can start asking questions on top of it. And we can ask, for example, what is the origin of the word cocktail? Cool. The origin of the word cocktail is disputed. It has been theorized that it evolved from the French cocktail for an ebb cup in which Antoine blah blah blah, creator of blah blah blah, alleged used to serve his guests a mix of cognac with a dash of his bitters. Another thing that we could ask is what is the history of cocktails? Cocktails in bullet points. And then we would get that the first recorded use of the word cocktails appeared in 1798. Then we have in 1917, there was the first cocktail party. And in the 2000s, cocktails become more and more popular. And the nice thing is that all this information are basically backed up by information in our PDF. So that basically we are not generating random knowledge, but we are really generating knowledge. Okay, so now we have seen how we can query structured data, how we can query unstructured data. So let's try to combine both of them. So we create a combined knowledge graph that is made out of a knowledge graph of a text, about a text document. No, why did my cocktails? Here we are. Sorry. Cocktails text, cocktails KG, and we are just creating a cocktail combined data set. And now, where is it? Here. And now basically we can ask something like cocktails with water. And we would get the cocktails that contain water. This would basically access the structured part of the data in our organization. And we can ask when was the first cocktail party in history? The first cocktail party was allegedly thrown by Julius blah 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 in May 1997. Okay, checking the time. Yes. So let me now describe some use cases that you can fulfill by using question answering technologies. So the first one is an HR use case. So basically what we have here is a knowledge graph about employees. If you just ask for employees, in fact, you get more or less all the data that we have. So we have the list of employees, the languages they speak, the programming languages. You have their age, their gross salary, and some other information. So in this case, we want to basically construct maybe or find a specific profile. For example, who can program in Java. And here we would get the list of all employees that can program in Java. We have also this list view. We can check their faces if we want. Yes, we could also ask that can program in Java and it's older than 40. Maybe this is a requirement. No, that's not exactly what I wanted. I think I wanted rather this thing. So we found one Java programmer that has more than 50 years, which is Blake Freeman. Or we could ask something like who can speak English. And we would get basically all employees that can speak this specific language. Another use case could be a customer 360 use case. In this case, we are basically have a knowledge graph which contains a lot of different types of entities like orders. So we have orders which include certain items with their quantities, to which cities they were shipped. We have employees, which is a bit more similar to the data we had before. And we could ask for orders by Mrs. Jen Leveling. And then we would get basically all orders that are made by this specific person or orders containing queso cabrales, which is a specific product. And here would be all orders of this particular type. Another use case more on clinical trials would be, here we took a clinical trial by Boehringer. It is 173 pages long. And we could start asking something like, what is this clinical trial about? So that's maybe something not trivial if you have a very, very long document. And here we get this clinical trial called Carolina trial. Is a multi-central international randomized parallel group double-blind study to evaluate cardiovascular safety of lingipeline versus glimepirine, whatever. We can ask what is lingipeline or whatever. Lingipeline is a DPP-4 inhibitor compound discovered by Boehringer Ingelheim, which is orally available with the low risk of hypovolemic episodes. And this is described at a very specific part of the document, in this case on page 25. So it's something that we probably would not have found so easily. We can try to ask what are the side effects of this drug. Didn't provide of the side effects. Okay, so this is maybe not exactly what we wanted, but we can ask something like what are the number of expected participants of the study? The expected number of participants of the study is not provided in the sources provided, and the reason is that basically this clinical study didn't start it yet, and so we do not find this information in this clinical study, which is nice because it means that the model is not giving us a random answer, but is really trying to only use the underlying knowledge to answer to it. Okay, so to conclude, I want to show you a ChatGPT clone. So this is running on our infrastructure. It's not ChatGPT, and I'm going to ask something like, "Hi, I'm at the end of a talk at the Knowledge Graph conference. Can you give me some final words?" Of course, here are some final words for your talk at the Knowledge Graph conference. In conclusion, knowledge graphs are powerful tools that enable us to represent and reason about complex information in structured and formal ways. Okay, so maybe we need to say him a bit more, something like, but my talk was about question answering over knowledge graph and text. Can you adapt? Of course, here are some final words for your talk. In conclusion, question answering systems that leverage both knowledge graphs and text are powerful tools that enables us to extract and reason about information from multiple sources. The ability to handle both structured and unstructured data opens up with new possibility for applications such as chatbots, catalog search, and knowledge management. As the field continues to evolve, it's important to stay up to date with the latest development and to explore new applications for these powerful systems. I hope you have enjoyed this talk and learned something new about question answering over knowledge graph and text. Thank you. And I think with this, I would like to conclude, and I'm happy to answer any questions if there are. Yes, so in general, you can ask questions in the chat, but also I'm around here at the Knowledge Graph conference, so if you want to interact in person, do not hesitate. We have a booth in the second floor. And yes, so one question from the chat are, what are you doing with the inputs, RTF files and documents to be able to query it in natural language? I understand this is a proprietary, but maybe some general insight. Are you translating natural language statements into Sparkle queries? Yeah, so that's exactly what we do. So basically, we take your knowledge graph and basically we index it locally. We create a Sparkle endpoint, as I was seen, but we can construct also some other database, other index structures. And then we take the natural language question, we try to see what node and edges it could correspond into the graph. And based on this, we then at the end generate a Sparkle query that tries to match the intent of the original question. And for documents, it's a bit similar. We index the document locally, and then we pass part of the documents that we think are more relevant to the language model in order to answer to questions. A second question is, how do you reconcile the RDF and text document? Do you extract structs from text and align them on the class properties of your ontology? No. So in fact, the two technologies are relatively distinct. So when we query text, we do not really use a knowledge graph under the hood. So our positioning is that if you want to query structured information and if you want to store and access structured information, then you use knowledge graphs. So you can take your JSON XML database and put it into a knowledge graph. But basically, the unstructured content in a document is not well suited to be put into a knowledge graph, and so we really separate these two things. Okay, thanks. So you can have answers with elements coming from both sources at the same time. So our observation is, in general, is that there is not a big overlap between the information sources that you can store in a structured way and in an unstructured way. But yes, I didn't show it in the demo, but when you ask a question, basically, we are trying either to redirect you towards the graph or the text based on what we think is the most probable to contain an answer. But you can also click to basically switch from the graph view to the text view and see what is the best answer in the other world. Can I try this out on my company knowledge graph somehow? Yes, so you can reach out and we can set up a demo with you. You can also try to do this yourself under app.qanswer.ai. There are some documentation for it. But yeah, the best that I would recommend is really to reach out, and we can set up a demo of you if you can share part of your knowledge graph, and we can iterate from there. Have you tested the ChatGPT clone in integration with the combined question answering? So basically, the ChatGPT clone is used basically in both technologies. So we are at the end, what we do is that we pass information to a language model at the very end, and it's the language model that is generating answers in a generative way. So basically, the three things that I showed you are tightly coupled together. Okay, thank you too. And yeah, otherwise, if you are around at the conference, do not hesitate to reach by. We have another talk tomorrow, which is not related to question answering, but more to knowledge graph infrastructure. We are speaking about the EU knowledge graph, which is a knowledge graph that we maintain for the European Commission that is using open technologies like Wikidata and Wikibase. So if you are interested in that, do not hesitate. And otherwise, see you around somewhere on this world. Bye-bye.